There is something living under the sand right now. Not deep under, not far away. Right there, beneath the ocean floor. In water shallow enough that people swim in it, dive in it, walk along the bottom of it. You cannot see it. The fish swimming above it cannot see it. Nothing can see it until the exact moment it decides to move. And by then, it is already too late. The bobbit worm is not the largest predator in the ocean. Not the fastest, not the most famous, but it is by a significant margin one of the most effective ambush hunters that has ever existed on this planet. And the way it kills is something that, once you understand it fully, will genuinely change how you think about the ocean floor. Let me show you exactly what I mean. First, let us establish what we are dealing with. Eunice aphroditois. That is the scientific name. It belongs to a group called polychaete worms, segmented marine worms, that exist in enormous diversity across ocean environments worldwide. Most polychaetes are small, harmless, ecologically important but visually unremarkable. Eunice aphroditois is not most polychaetes. It reaches lengths of up to 3 meters, nearly 10 feet of segmented, armored, muscle-dense worm body coiled beneath the seafloor, completely invisible, completely still. Its body is covered in bristles, small, sharp, silica-based structures that line every segment. In some species of polychaete, these bristles are purely defensive. In the bobbit worm, they serve an additional function, anchoring the body inside its burrow with such mechanical efficiency that pulling one out by force requires significant effort. It does not want to come out. It only comes out on its own terms. And when it does, everything nearby pays attention. Understanding the bobbit worm requires understanding the burrow, because the burrow is not just a hiding place, it is the entire hunting system. The worm excavates a tunnel in the seafloor in sand, in mud, in sediment and positions itself vertically inside it, body pointed downward, head at the surface. The burrow can extend 2 to 3 meters straight down. This means the worm's body 3 meters long fits entirely beneath the surface with essentially nothing visible above the seafloor. Nothing except 5 antennae. 5 small sensory structures that project just barely above the surface of the sand. To anything swimming above, they are invisible, indistinguishable from the seafloor. But those antennae are extraordinarily sensitive instruments. They detect vibration in the water column above. They sense pressure changes created by movement. They respond to electrical signals, the bioelectric fields produced by the muscle activity of nearby fish. Every fish has a bioelectric signature, a faint electrical field generated by its nervous system and muscles. The bobbit worm reads that signature. It knows something is there before it can see it, before the fish has any idea the worm exists. The worm waits in complete stillness, sometimes for hours, while fish swim directly above its hidden antennae, waiting, measuring, deciding. And then it decides. What happens next has been captured on high-speed camera, and watching the footage, even knowing what is coming, is genuinely shocking every single time. The strike speed of the bobbit worm has been measured. Approximately half a meter per second, the entire front portion of the body launches upward from the burrow in a single explosive motion. That number sounds slow until you consider the mechanics. The worm is not chasing prey. It is not swimming toward prey. It is exploding from directly beneath prey that had no awareness of its presence. There is no escape response fast enough. By the time the fish's nervous system registers that something has happened, the worm has already made contact. The jaws, called pincers or mandibles, are made of a zinc-hardened biological material called sclerotite, zinc-reinforced protein, a biological composite that combines hardness with flexibility. These jaws close with a force that has been documented, splitting fish bodies cleanly, not biting through, not tearing, splitting. The strike is fast enough and forceful enough that in documented cases, the fish is cut in half on contact. The front half disappears into the burrow in a fraction of a second. The back half, still twitching from severed nerve signals, drifts away in the current. The seafloor looks undisturbed. The worm is already gone. The whole event takes less than a second. Let us spend a moment on those jaws, because they deserve proper attention. The bobbit worm's jaw structure is called a gnathabdelida, a complex arrangement of multiple interlocking sclerotite components that work together. There are 2 primary grasping structures that extend outward and inward simultaneously on the strike, functioning both as a cutting mechanism and as a grasping mechanism in a single motion. The zinc reinforcement is not an accident or a minor detail. Zinc-hardened biological materials appear in several predatory marine invertebrates, including certain claw structures and other polychaetes, and in mantis shrimp. The incorporation of zinc ions into the protein matrix of the jaw increases hardness by a significant factor without increasing brittleness. It is, essentially, a biological engineering solution to the same problem a tool manufacturer faces when designing cutting equipment. How do you make something hard enough to cut without making it so hard that it shatters on impact? The answer in both biological and industrial contexts involves composite materials. The bobbit worm evolved this solution independently, without an engineer, without a laboratory, without a materials science department. Over millions of years of trial and error, it arrived at zinc composite cutting jaws, and they work well enough to split a fish in a fraction of a second. In 2009, something happened at the Blue Reef Aquarium in Newquay, England, that became one of the most widely discussed events in marine biology circles that year. Staff at the aquarium began noticing problems with one of their coral reef display tanks. Fish were disappearing, not dying visibly, not showing signs of illness, disappearing overnight. Then the coral began suffering, showing damage that staff could not attribute to any known cause. Then pieces of live rock, the natural rock structures used to build reef displays, began showing unexplained damage overnight. The staff conducted investigations. They checked water chemistry. They reviewed feeding protocols. They examined every fish in the tank individually. Nothing explained it. They set a trap. A length of fishing line baited and run along the bottom of the tank overnight. The next morning, the line had been cut. Not broken, cut, cleanly severed. That was when they decided to fully dismantle the tank. Everything came out. Every piece of coral, every rock, every decoration, every component of the display. And at the very bottom of the tank, buried in the substrate, they found it. A bobbit worm, slightly over a meter long. It had entered the facility inside a piece of live rock, standard aquarium material sourced from the ocean, and had been living undetected in the tank for what investigators estimated was several months, hunting every night, in a controlled, monitored, professionally maintained facility, surrounded by people who worked with that tank daily, completely invisible the entire time. The aquarium staff removed it, documented it, and in a detail I find somewhat remarkable named it Barry the bobbit worm, who had been silently dismantling their reef display for months, and nobody knew until the fish were gone. Here is the part that most people do not think about until after they have learned everything above. Where does the bobbit worm live? The answer is broader than you probably want it to be. Eunice aphroditois has been documented across a genuinely wide geographic range: Indo-Pacific waters, the waters around Japan, the Philippines, Indonesia, Australia, the Atlantic, Caribbean waters, waters off the coast of Florida, the Mediterranean. It prefers relatively shallow tropical and subtropical waters, typically between 1 meter and 40 meters of depth. 1 meter, that is shallower than many swimming areas, shallower than most recreational dive sites. It lives in sandy and muddy substrates, the kind of seafloor that exists in enormous abundance in coastal zones worldwide, the kind of seafloor people wade through on beach vacations. Now, to be precise and accurate, documented attacks on humans are essentially non-existent. The bobbit worm is not hunting humans, it is hunting fish, small fish, the prey it has been evolutionarily calibrated to target. But there are documented cases of divers receiving lacerations from bobbit worms when they disturbed a burrow unknowingly. The worm responded defensively. The bristles can also cause skin irritation on contact. A mild venom in the bristle structure produces a localized reaction. So it is not hunting you, but it is under the sand, in shallow tropical waters, right now, and it is worth knowing that. Here is something that most videos about the bobbit worm skip over: the reproduction. Eunice aphroditois reproduces through a process called epitoky, a reproductive strategy found in several polychaete species that is, in its own way, as strange as the worm's hunting behavior. When the time comes to reproduce, the rear segments of the worm's body transform. They develop specialized muscles, paddle-like appendages for swimming, and packed reproductive cells. These rear segments, still attached to the main body, essentially become a separate organism within the body, and then they detach. The transformed rear portion separates from the worm, swims to the surface independently, and releases its reproductive cells into the water column. The main body, still in the burrow, regenerates the lost segments over time. It does not die. It does not even leave the burrow. It sends part of itself to the surface to reproduce, and then regrows what it lost. This strategy allows the worm to reproduce without ever exposing its primary body to surface predation. It stays hidden, it stays safe, and it sends a biological representative to handle reproduction on its behalf. This is not a primitive strategy. This is a sophisticated solution to a specific ecological problem. How do you reproduce when your survival depends on never leaving your burrow? You do not leave. You send part of yourself instead. The bobbit worm is not a monster. I want to be clear about that. It is not evil. It is not aggressive beyond what its survival requires. It is not aware of the effect it has on the people who learn about it. It is simply extraordinarily well designed, for one purpose: ambush. Everything about it, the burrow depth, the zinc-reinforced jaws, the zinc composite cutting structure, the sensory antennae, the strike speed, the reproductive strategy that never requires leaving the burrow, every single feature points toward one evolutionary goal: stay hidden. Strike once, never miss. It has been doing this in essentially the same form for an estimated 20 million years based on fossil evidence of related eunicid species. 20 million years of refinement on a single strategy. And it works so well that a specimen once lived undetected inside a professionally maintained aquarium for months, in a controlled environment, surrounded by trained staff. And nobody knew, until Barry had already eaten most of the fish. That is not a horror story. That is biology, and the ocean is absolutely full of it. If this is the kind of content that genuinely interests you, the real, documented, peer-reviewed, stranger-than-fiction natural world, then you are exactly the kind of person this channel exists for. Subscribe, because there are hundreds more of these waiting, every single one of them real, every single one of them in the ocean right now.